Okay, let's go ahead and sketch this vector field. 2x times unit vector I plus y times unit vector j. Again, I kind of like component form for this, so I'm going to write this one in component form. It has components 2x and y. Now, in order to sketch this thing, we need to look at the level curves, which means we're going to need the magnitude of our vector field, and the magnitude of this will be the square root of each of the components squared. So it is the square root of 2x quantity squared plus y quantity squared, which should give us the square root of 4x squared plus y squared. And then what we're going to do is we're going to set that magnitude equal to some constants. And again, I'll just do at least two of them. You need at least two to get an idea of what you got going on here. And I'll do c equal 1 and c equal 2. So for the first one, again, remember what we're doing. We're setting this magnitude then equal to 1. So we've got the square root of 4x squared plus y squared is equal to 1. You're going to want to come in and square both sides, which is going to give you 4x squared plus y squared is equal to 1. And this actually gives us an ellipse. See if we can remember how to do this here. And we don't really have to make a huge deal out of this. I think we can do this without having to go through a whole issue on conic sections. This should not be a really, really big deal to us because we've done this before, but let's look at what we've got here. Looking at this ellipse that I'm going to sketch here, first off, let's let x be 0. Then I get y squared is equal to 1. Take the square root of both sides, and I get that y would be plus or minus 1. On this side now, I'm going to go ahead and I'm going to eliminate the y variable. I get 4x squared is equal to 1. I would want to divide both sides by 4. I get x squared is equal to plus or minus 1, a square root of 1/4, or plus or minus 1/2. And so what I have then is this ellipse here. And so again, what we're going to do, this is passing through the points, by the way, 0, 1, 1, 0, and 1/2, 0, negative 1/2, 0. And so let's go ahead and look at then what our vectors look like originating from each of those points. So let's see, that was 1/2, 0. That was negative 1/2, 0. That was 0, 1, and 0, negative 1. And now remember, to do our vector field, or to look at what those vectors look like, we got to go back to the rule for our vector field. And the rule for our vector field says that the first component for each of these vectors is going to be 2 times the x coordinate. So that's 2 times 1/2, which is 1, 2 times negative 1/2, which is negative 1, 2 times 0, and 2 times 0. I tend to like to do all my x component, all my first components, and then all my second. And the second components are just y, so that's 0, 0, 1, 1. And so we now know what the vectors look like coming out of each of these points. So when we're at 1/2, 0, we have a vector of length 1, which goes in the direction of 1, 0. And let me get some more points in here so we can see where we need to go with that. Okay, so that's my value of 2. So I'm going to go 1 unit out. When I'm at negative 1/2, I'm going to go 1 unit out. 0, 1, I'm going to come 1 unit up. And 0, negative 1, I'm going to come 1 unit down. Okay, let's go ahead, and I'll use a different color here, maybe to make it easier to see. We'll do our constant then equal to 2, or our magnitude equal to 2. So we will set this magnitude equal to 2. Remember, the magnitude was the square root of 4x squared plus y squared. Setting that equal to 2, we'll square both sides. We get 4x squared plus y squared is equal to 4. And once again, we have an ellipse. Let's see what that ellipse is going to look like. If I were to let the x component go to 0, I'm going to get that y is equal to, and that should be on the end right there. I'm kind of off a little bit on that. Y is going to be equal to plus or minus 2. If I let the y component go to 0, I divide both sides by 4, and I get x squared equal to 1, so x will be plus or minus 1. So I have this ellipse here. This is for my c equal to 2. And so I can see the points that this thing goes through. It goes through the ordered pair 1, 0, through the ordered pair -1, 0, through the ordered pair 0, 2, and through the ordered pair 0, -2. And then, of course, each of the vectors that I get are going to be based on my vector field rule. And these are going to have a magnitude of 2. And we know that because we set that magnitude equal to 2. So again, using my rule for my vector field, I don't know, I just find it easier if I'm going to do some to do all the x ones at once, or all the first components, I should say. So that's 2 times 1, which is 2, 2 times -1, 2 times 0, and 2 times 0. And then I'll do all my y components, my second components, which are y, 0, 0, 2, and -2. And so we see then we're going to get our vectors here, and I didn't leave myself an awful lot of room, but these vectors are going to be these two in this direction and 2 units long going in these 2 directions here. And of course there are more vectors. We're not showing them all, but there should be a vector here that originates at length 1 that keeps this kind of thing flowing, and you're more than welcome to find those. And we probably would if we were going to sketch this thing. But again, we at least get an idea of what's happening with our vector field.